Good morning and welcome to this third session on experiments in biology. I'm your facilitator for this session, Dr. Anita Koso, and today I'll go through the third learning outcome with you. The session is recorded, so if you want access to it, sorry, we will provide the links on WhatsApp as well as on Moodle. So starting with the third learning outcome, this is to discuss and evaluate the data collected and the conclusions drawn. Okay, so the previous session, the first session that we had so far done was developing hypotheses and safely measuring and recording data. The second learning outcome was it was to understand the data collected and drawing appropriate conclusions. Now we're doing the third learning outcome, which is to discuss and evaluate the data collected and conclusions drawn. I hope you can see my screen and my voice is audible as well. So the third learning outcome is to identify any trends or patterns and any anomalous measurements in the presented data. So the data that is presented to you, do you see any trends? Do you see anything that is not normal? For learning outcome 3, the learner is expected to demonstrate a clear, independent ability to recognize certain trends and anomalies across the data set as a whole, and you would be showing confidence and consistency in data handling. This learning outcome focuses on the overall patterns across all results, consistency and repeatability of the trends, and identification of anomalies with justification. So it's not just identification of the anomalies, but also justifying why do you see these anomalies and what could be the remedy for this. It goes beyond spotting a single trend and looks at how reliable and coherent the data set is. So you need to see the quality of the data set. What is the data set actually telling you about? So the example, there's several examples that we had discussed earlier. We are now discussing an example of osmosis in chipped potato. In blackcurrant squash. So across all concentrations tested, the data has shown that there is a consistent pattern where we increase squash concentration, and that leads to a greater loss of mass in potato chips. Lower concentrations result in mass gain or minimal change. So either there'll be minimal change or there'll be a gain in the mass in the potato chips, while higher concentrations result in progressively larger mass losses. This pattern is consistent across the data set. So as many times as the data set was analyzed, this was consistent. We had seen the same findings across the data set, and this shows a clear relationship. So when you see consistency in associations or results, this shows a clear relationship between solution concentration and mass change. One result at 10% concentration shows a small increase in mass compared to the neighboring values. This measurement can be identified as anomalous because it does not fit the overall downward trend. So this anomaly is minor. So that's just one thing that was abnormal. And this may be due to experimental variations such as uneven chip thickness or residual surface liquid affecting the mass reading. An example of enzyme concentration on reaction rate. So the data shows a strong and consistent trend in which increasing enzyme concentration results in shorter reaction times. So when we increase the enzyme concentration, this leads to shorter reaction times. Reaction time goes faster. This pattern is observed across all concentrations tested and is supported by repeat measurements, indicating a reliable trend. So again, when it was repeated, it showed the same trends, which shows that there is reliability in the findings. There was one measurement at 2% enzyme concentration, which produced a longer reaction time than the other repeats at the same concentration. This value is considered anomalous again because it deviates from the expected pattern and the surrounding data points. And the possible reasons would include delayed timing or inconsistent meeting. Now coming towards discussion of the accuracy. Uh, just a minute, sorry. Sorry for that. Yes, to meet the criterion, when we want to discuss the accuracy of the collected data, to meet the criterion, the learner must show that they understand what affects accuracy and trust and how trustworthy their measurements are. This includes precision of the measuring equipment. I'm so sorry for this background sound. Um, yeah, we are having some distortion. I'm so sorry. Precision of measuring equipment. So in order to make it more accurate, this needs to be more precise. Uh, So the precision should be there of the measuring equipment. There should be consistency of measurements. Human error should be reduced as much as possible during measurements. Whether values were recorded correctly or not, that has to be seen. Examples of an example is osmosis in chipped potatoes. So the accuracy of the data collected, excuse me, was generally good because digital balances were used. Anything that is digitalized gives it a more reliability, and this allows the mass to be measured to 2 decimal points, and the measuring cylinders were also used. Hmm. And n- so this ensures equal volumes of the solutions that were added to each beaker. Potato chips were cut to similar sizes to reduce variation, although small differences in thickness may have affected the accuracy of mass readings. Some surface water may not have fully removed before weighing, which could have slightly increased the mass, which was the final mass, which was recorded. Despite these limitations, the overall accuracy was sufficient to identify clear patterns in the data. Now, an example of effect of enzyme concentration on reaction time. So the accuracy of the reaction time data was reasonable because a stopwatch was used to measure, and this was done to measure in seconds. And the observer recorded all the timings. However, human reaction time. However, human reaction when starting and stopping the stopwatch may have introduced some inaccuracies. Measuring cylinders and pipettes were used to measure enzyme and substrate volumes, increasing the accuracy. Any minor inaccuracies did not significantly affect the overall trend observed in the results. Key accuracies that were accuracy factors that were discussed are equipment resolution. So, for instance, you could include decimal places, consistent measuring methods, control of variables, and impact of small errors on results. Now, to meet this criterion, uh, the last bit that we're talking about is to evaluate any anomalous measurements, observations, and suggest reasons for them. So, to meet this criterion, the learner must identify specific anomalous results, and explain why they are considered anomalous. Explain and evaluate how they may have impacted the overall results, and to suggest realistic reasons for their occurrences. Now, an example is osmosis in chipped potatoes or blackcurrant squash. One anomalous result was observed, you can say this if there was any, and where a potato chip, it was at 10% concentration. And this happened where the potato chip showed a small gain in the mass despite the overall um, trend of decreasing mass with increasing concentration. So this measurement is considered anomalous because it does not follow the general pattern, the general trend that we saw in the rest of the data. This anomaly has a limited impact on the overall results because the remaining data points still show a clear trend, and the anomaly does not significantly change the shape of the graph or the conclusion. A likely reason for this anomalous result is that the potato chip was slightly thicker than the others, so there can be human error introduced, reducing the rate of water movement. Another possible reason could be that excess surface fluid was liquid was not fully removed before weighing, artificially increasing the recorded mass. Now we come to the effect of enzyme concentration on the reaction rate. An anomalous observation occurred during one trial at 2% enzyme concentration, where the reaction time was longer than the other repeat values. This value is anomalous because it deviates from both the repeat results and the overall trend of decreasing reaction time with increasing enzyme concentration. The effect of this anomaly on the final outcome is minimal because mean values were calculated and the general pattern remains clear. Possible reasons for this anomaly include the delayed timing when starting or stopping the stopwatch. Inconsistent mixing could be there of the enzyme and the substrate, or there could be a slight variation in enzyme quantity added during the trial. Now we go on to evaluate the suitability of the practical procedure. To meet this criterion, the learner must evaluate how appropriate the practical method was for achieving the aim and testing the hypothesis. This includes whether the procedure allowed a valid data to be collected, how were variables controlled, how well were they controlled, practical limitations of the method, whether the procedure could realistically be repeated. So an example of this is osmosis in chipped potato, blackcurrant squash, the practical procedure used to investigate osmosis in chipped potatoes was generally suitable because it allowed the effect of solution concentration on mass change to be clearly measured. Using potato chips of similar sizes made the experiment simple and accessible, and measuring the mass before and after immersion provided a more quantitative data that could be compared across the data sets. However, the procedure had limitations. Cutting the potato chips by hand made it difficult to ensure identical surface area and thickness, which may have impacted water movement. The length of time the chips were left in the solution may also have varied slightly, affecting results. Despite these limitations, the procedure was suitable for demonstrating osmosis and identifying overall trends, even if it lacked high precision. And then the effect, now we go on to see the effect of enzymes on reactions. The procedure used to investigate enzyme activity was suitable because it allowed changes in reaction rate to be observed by measuring time and gas production. The use of repeated trials improved the reliability of the results, and controlling temperature and substrate volume helped maintain consistency. However, the procedure relied on manual timing, which introduced human error. The reaction was also occurring more quickly at a higher enzyme concentration, which makes precise measurement more difficult. While these factors reduce precision, the procedure remains suitable for identifying any relationship between enzyme concentration and the reaction rate. The key evaluation points covered were fit between aim, hypothesis, and methods, strengths and limitations of the procedure, impact of limitations on data quality, and overall judgment of suitability. Now we go on to recommend modifications to the practical procedures. To meet this criterion, the learner must suggest realistic practical improvements, link each modification to a limited identified limitation identified earlier, explain how the change would improve data quality, uh, accuracy, and reliability. You cannot use vague statements like "be more careful." This does not this does not meet the criterion. An example of this is osmosis in chipped potatoes in blackcurrant squash. One modification would be to use a cork borer or potato corer to produce potato samples of identical diameter and thickness. So this would reduce the variation in surface area and volume, and this would improve in turn the accuracy of mass change measurements. Another improvement would be to blot each potato chip using the same method and for the same amount of time before weighing. This would reduce the effect of excess surface liquid and make the mass readings more reliable. The experiment could also be improved by increasing the number of repeats at each concentration and calculating a mean value. This would reduce the impact of anomalous results and improve confidence in the overall trend. An example is the effect of enzyme concentration on reaction time. Key modification would be to use a gas syringe instead of a visually estimating gas volume or relying on or only on timing. And this would allow more accurate measurement of oxygen produced and provide more precise quantitative data. Using a water bath to maintain a constant temperature throughout the experiment would also improve the method, as enzyme activity is temperature dependent and small fluctuations would result in could impact the reaction rate. Finally, using automated timing or video recording rather than a hand held stopwatch would reduce human reaction time error and improve accuracy. I hope this session was valuable to you. These are some of the references that have been used in putting this presentation together. If you have any questions, please email us at learnerwork@ukversity.co.uk. Your submission of your assessment will be once we have done the assignment discussion. This will have and the submission deadline will be after 2 weeks of completion of the units. So this recording will be shared with you as in due time. Thank you so much for your time, and I hope to see you soon. Thank you. Bye.